Hello, my name is Jaasveer from class DDT4GS5. My card matrix number is 21DDT19F1191 and our code and course is DSC40163 System Analysis and Design. Okay, me and my friends are going to discuss about our project 1 in this SKD subject, and I'm going to do question A and B. Okay, for this, the question for this subject is stars is a team base. Each group consists of 3 to 4. So our group consists of 4 people. Me, Darshan, Harisuriaa, and Saranya. And based on the project title, our project title is Smart Street Light, Automated Smart Street Light that has been discussed previously. Your group are required to prepare system analysis and system design for a project. Okay, let's get started. Okay, for this part A, design a functional decomposition diagram FDD for your project system. So my project is, as you can see here, it's a smart street light. Let me just zoom it a bit. Okay, it's a smart street light. Okay, in this function, we have three sub-function, users. First, we have the staff and the sensors and the users. First, the staff, we have one sub-function from staff, which is update. We have to let the staff to regulate monthly or maybe twice a month to update the system. So in this update, we have another two sub-functions which are system sensor input and temperature trigger. In this sensor input, we need to check whether the sensors are properly working and the temperature are all correct. The temperature trigger is always like correct. Okay, next we have sensor. In this sensor, we have two sub-functions, light intensity and temperature. In this light intensity is like if it's getting darker, like at night around 6 or 7 getting darker, the light will on during that time. Like if it's like 7 o'clock, the light is like 25% darkness. If like 10 o'clock, 11, 12, something like that, it will become darker, like 100% dark brightness. So it's based on the light intensity. It saves electricity and a lot of things. Next we have temperature. Okay, this is a second backup for light intensity. If the temperature is above 30 degrees, it will on certain based on which country you are from. Example, if you are from Malaysia, the temperature is basically 35 degrees and below, it will on. Because at night, we have cooler air and cooler temperature, so it will on at that time. And next we have the user. There are also two sub-functions which are initialization and finalization. These users start the output and also end. Like if there's a movement, it will on. If there's no movement, it will off. Alright, that's from user. Okay, next we have design a context diagram for system. This is a context diagram. As you can see here, my project title is in the middle, which is smart straight light. And first we have the light intensity, which is the input. The darkness it's based on the light intensity. If 25% or less, it will on the light, which is a dimmer light. If above 50%, it will be a bit more brighter than the 25%. Alright, and then if it's at midnight, it will on the darkest because it's very dark and scary, right? So it's a lot more safer. Next, we have the second input, which is solar charging. This is a solar charging method which save a lot of electricity, which only provides solar charging, which is less expensive. It's not even expensive at all. It's like during the daytime, it will not just sit down there and do nothing. It will charge for 7 to 9 hours. Alright, each lamp. So it will take that time to absorb the sunlight and to charge it. At night, it will fully function. Next, we have the input output, which is sensor initializing. Okay, this is like the input to take and in. Like you give the sensor instruction and you get the instruction. It's like first you give is like if you above 25 degrees Celsius, you're on. Then when the 25 degrees is on, it will come give you as an input. Alright, after the sensor initialization, we have another output, which is the lamp will on or off. Okay, this is like the start button on and off. Okay, the another output is the lamp light. Something seem like on and off, but it's like which makes the light come on. Alright. Okay, that's it from me. Okay, now I think my son will continue from C to D. Alright, that's all for me.
Hello, hello to my lecturer upon Shuhada and my fellow classmates. My name is Darshan Sri, and I'm here to present about design a data flow diagram DFT level 0 for your system and provide explanations. Okay, so this is my DFT level 0 diagram. It's a very simple diagram. It's actually something similar to Jaasveer's one. I just did it in this way, and I have my explanations. So okay, our main project is smart street light system, and this is lamp light and this is lamp off, on off. So the smart street light system, what it will do, what the system is, it actually detects whether the surrounding is dim or bright, and it will it will detect whether the surrounding is dim or bright, and it will let know to the lamp light. And the lamp what the lamp light will do is the lamp light will apply enough how to say enough light according to the scenario. Let's say it's like 7 o'clock in the night, it's still bright, right? So the the street light will on, but then it will just emit just a bit of light. But then when it becomes darker, as the night goes darker, the the scenarios also changes darker, right? So then as the night goes darker, the lamp light will initiate to emit even brighter light. So this is how dim bright system works. And then we go to solar charge. Solar charge is um, actually nowadays lights are going solar, so that they don't need to use electricity. It saves money as it saves electricity. And solar, what they'll do is in the morning they will recharge their lamp, at night it will go fully, it will emit full light, because since morning we don't need to use the street light, so morning it will use as it will recharge itself. So the solar panel is like a recharger. And then initializing sensor. So what initializing sensor does is our smart street lights program is programmed to be when like there's movement, only our light will work. So in this way we can save the our bulbs lifespan, and also we can save costs. So when people is moving, the sensor will initiate, the sensor will send movements, sorry, the sensor will send movements to the system, and the system will initiate for the light to on and off. And then this is just a normal start. So when the sense when the smart street light gets all these three, sorry, not three, sorry, when the sensor when the smart sorry, when the system get these two dim bright situation, and detects movement, it will initiate the lamp to on. So it's a very simple diagram, and that's all. Thank you. Next, Hari will present, so thank you.
Hello, my name is Harisuriaa from class DDT 4G. Okay, now I'm going to present about creating a DFD level 1 diagram based on question C. Okay, so the first main process that I found is the start process. Okay, so first of all, the LDR, which is electrical component, will compare its value get from the solar charge, which is from the sunlight, to the threshold value, which was set by the programmer, which is stored in the system. Then, if the LDR value is at a specific value, the LDR tells the IR transmitter, which then operates the light and sends to the LED lights, and the LED lights displays the lights as the traffic light starts working as it's programmed. Okay, the next one is the dim and bright process. Okay, so the LDR compare its value from the solar charge, which comes from the sunlight, with the threshold value inserted from the programmer. Okay, so if the solar charge value from the LDR is equal or above the threshold value, which was set by the programmer, then the LDR tells the IR transmitter to operate the lights brighter. But if the solar charge value from the LDR is below the threshold value, the LDR tells the transmitter to dim the light, which then the IR transmitter transmits the light to the LED. The LED then displays the amount of light the IR transmitter transmits. So the light usually dims during night because the sunlight is low, and then the LDR value will also be low. Okay, so the next one is initializing sensor. Okay, so the before the sunlight goes to the LDR, first of all, the IR receiver, which acts as the sensor, the receiver is the one that collects the solar charge from the sunlight, which then transmits to the solar charge to the LDR. Okay, then in the same process, the LDR will compare its value get from the solar charge to the threshold value set by the programmer, which is stored in the system. Then if the LDR value is at a specific value, then the LDR tells the transmitter, which then operates the light and sends to the LED lights, and then the LED light display the traffic lights as it's programmed. Okay, so that's all from me. Thank you. Okay, hello, my name is Harisuriaa from class DDT4G. Okay, now for project SAD, I'm going to present about this question D, which is based on question C. Okay, so the three main process I found, one of it is start process. Okay, so how it works is, first of all, the LDR will compare its value get from the solar charge to the threshold value set by the programmer, which is stored in the system. Then if the LDR value is at a specific value, the LDR tells the IR transmitter, which then operates the light and send to the LED lights, and then the LED light displays the light as the street light starts working as it's programmed. Okay, the next process I found is the dim and bright process. Okay, so the LDR compare its value from the solar charge, which comes from the sunlight, with the threshold value. If the solar charge value from LDR is equal or above the threshold value, which was set by the programmer, the LDR tells the IR transmitter to operate the lights brighter. But if the solar charge value from LDR is below the threshold value, the LDR tells the IR transmitter to dim the light, which then the IR transmitter transmits the light to LED. Then the LED displays the amount of light that the IR transmitter transmits. Okay, so the last process I found is the initializing sensor. Okay, so the IR receiver acts as the sensor. It collects the solar charge from the sunlight, which then transmit the solar charge to the LDR. Then the LDR will compare its value get from the solar charge to the threshold value set by the programmer, which is stored in the system. Then if the LDR value is at a specific value, the LDR tells the IR transmitter, which then operates the light and sends to the LED lights, and then the LED lights display the light as the street light starts working as its program. Okay, so these are the three main processes I found. First of all is the start process, the dim bright process, and then the final one is the initializing sensor. Okay, so that's all from me. Thank you.
Good morning, Juan. So my name is Saranya, and today I'm going to explain about question E. So first is select one main process from DFD level 1 design in D other than logging process. So you have to design the interfaces flow for the process by applying the A user interface design guideline. So first one is interfaces design flow. So this is my image. This is my diagram for interfaces design flow. So the explanation is, so above diagram shows the input and this is the input and process this is the process and this is the input interface of smart street light, and our smart street light automatically turns off during the nights because the smart street light has an IR transmitter and receiver and LDR. The LR receiver first receives the amount of light from the sun as the input. If the LDR value is above threshold value, which is set by the authorities, then it goes to IR transmitter. Then the IR transmitter transmits to the LED and the lights works as its program. So this is the diagram for process and this is the diagram for input. So next, so this is the diagram for interfaces design clarity. Next, the explanation. The smart street light works as its program. All the smart street lights has to work simultaneously in an area, and it also has to work as its program. The smart street light have to work in all area as program. So it is not just with an area, have to work in all areas. Next is usage of the guideline applied in the interfaces with a clear label of explanations. So this is our USB slot that have to connect with a computer system, which is this one. Okay. So the circuit board and the programs of the smart street light can only be accessed by auditories and staff. So it could only be accessed by inserting a USB cable that is connected to a laptop. Then the auditory has to click on a certain software where it shows the ID of the smart street light, and then the auditory has to enter his ID and password. So once it's right, the square shaped board opens and the auditory is able to access the codes and the circuit board. So design a transparent interface, simple login interface which has login and password to enter, and below got rows of street lights, the numbers of street lights. Okay. Next is create an interface that is easy to learn and use. In login interface have login and password text box to enter and buttons below for number of street lights. So provide feedback to users. Public can contact the auditories for repairs. For example, the smart street light doesn't work. Make it easy for users to obtain help or correct errors. Ensure that help is always available for the public. So next is enhance user productivity. So easy rows of smart street light menu in the system. Okay. Last one is explanation of how the interface is designed work based on DFD level 1 process. So first of all, the sensor initializes and senses the sunlight. Then the process starts. The sensor sends the value to LDR. The LDR compares the value with the 3 volts value. If the LDR value is higher than the 3 volts value, then the light gets brighter. If the LDR value is lower than the 3 volts value, then the light dims. So this is the bright or dim process. So that's all from me today. Thank you so much.